So let's grab the table. I already have the table right here. All right, so we're gonna play straight this time. We're gonna do both columns like we should have, not cheat. That's on me. And my loss matrix is 0, 1, 1. Where do I put it? So I'll put it here. 0, 1, 1. Oops. 1, 0, 5. 1, 0, 5er. And like one there. 1, 1, 0. 1, 1, 0. All right, so if you want to interpret it, remember our part does everything alphabetically. All right, what we're saying here is that when the model predicts orange, we cannot have orange predict cherry incorrectly. I'm sorry, we cannot have the model make the mistake of predicting something that's actually cherry to be orange. For whatever reason, that's problematic for us. Okay? So that is the only, for the sake of this matrix, that's the only one we're really concerned about. The fact that we want to penalize orange classifying, we want to penalize the model for classifying orange as cherry. It's 5 times worse than a normal error. Okay? So given this, let us do the splitting function. I don't know why I chose orange, because orange is the least of them. But let's work it out. All right, we'll work it out anyway. All right, so we got to do both columns. Remember, in the question I said assume min bucket of 3. So that's going to help us cut down the amount of calculations we have to do. Thank God. So we're going to do sugar.level first, and then we'll do pill.width. All right? And pick what our splitting value is. Now, let's go ahead and put all of the values out there. It's going to be 1.5, 1.6, 1.7, 1.8, 1.9, 2, 2.1, and 2.7. I believe I got them all. 1.6, 1.7 is pretty much continuous at this point, up till 2.1, and then we just jump to 2.7. All right. And so let's do the math. Do I want to start with 1.5? How many things are less than 1.5? Nothing. 1.5 is out. How many things are less than 1.6? 2 things. Cherry, apple. So just 2 things. All right. So 1.6 is out. All right. Let's work for me. All right. Now we go to 1.7. 1.7. How many things are less than 1.7? We got this apple, this orange, that cherry. That makes the cut. 1.7 is where we start with. Let's just make that bold. And in terms of greater than, so greater than equal to 2.7 is just 1. Greater than equal to 2.1 is 2. Greater than equal to 2 will get me my 4 values. So I'm going 1.7 to 2. Awesome. So basically only 4 values I have to check. That is great. Let me go ahead and grab, these icons. And let's get to work. All right, so less than, might as well just make this bold too. So these are 4 values for sugar.level I'm checking. So less than 1.7 is how many values? What's less than 1.7 is basically going to be cherry, orange, and apple. Cherry, orange, and apple. All right, so we got them all. We got one apple. Oops. One cherry and one orange. All right. Yep. 2.5 cherry, orange, apple. Excellent. Greater than equal. All right. Greater than equal will be everything else. So that will be how many apples? 1, 2, 3, 4, 5 apples. So 4 apples. How many cherries? 1, 2, 3, 4. So that would be 3 cherries. And how many oranges? 1, 2, 1 orange. And that should give us 3 plus 7 plus 8, which is 11. We have them all. We have them all. All right, excellent. Now, okay, now this is where this Gini, the loss matrix, comes into play. All right, let me go ahead and grab some of those other equations. All right, typically, what would we do? We have 3 over here. We would do 1 divided by 3, 1 divided by 3, and 1 divided by 3. All right? But with the loss matrix, we can't do that. With the loss matrix, what happens here is anywhere where you have a cherry, okay, where you have orange prediction, we have orange predicting, oh, this is also problematic, guys. Oh, no. Okay, so this is the way it works. So when you have the split, right, we're supposed to have a majority in our left node. Remember, this side is our left node, greater than equals our right node. So whatever is the left node, it has to give us a majority of some kind. We're not getting a majority. Again, I apologize. We're not getting a majority again. So let's assume cherry is going to be the majority. Again, we're cheating. We're just making something we're just making something off the cuff a majority for the left side. The right side will work better. I'll show you guys that. So left side, let's assume cherry is the majority. So therefore, the left, if it's less than 1.7, this would predict it to be a cherry. Okay? So cherry is the prediction. I go to my loss matrix here. Where's the cherry prediction? It's the cherry column. Is there any additional weights needed there? There aren't. There aren't, right? Everything's fine. There's no additional penalization for predicting, for the model predicting something as cherry when it's something else. In other words, a false positive of a cherry, right? So therefore, this equation will be straightforward. It'll be 1 divided by 3, 1 divided by 3. Done. All right? Now, let's go to the right side. Just copy this, move it over. Sorry. All right, so before we even look at the calculation, 4 apples, 3 cherries, 1 orange. Therefore, the right side is predicted to be apples. The right side predicted to be apples. I go to my loss matrix. Again, predictions are the columns. There's no penalization for incorrectly predicting an apple. Or I'm sorry, there's no penalization for the model predicting something that's an apple that in actuality is something else. Okay, there's no false positive. That's only here for oranges. This is a mistake. This is a mistake because we're not going to have a situation in play. I'm going to make a change on the fly. I'm going to make that change on the homework. I'm going to change apple to this. I'm going to change to 5, and this I will change back to 1. All right, and that's so that we can have a proper calculation. All right. So now I changed the loss matrix. Again, in the homework, I'm going to go and change the loss matrix and The beginning of this video is going to be kind of weird for you guys because you're going to see a different loss matrix, and now in the homework I'm going to change the loss matrix, and you're going to see this. So sorry about that, but I want you guys to get a better feel for this. All right, so now here the right side is predicting apple. Yes. Here we have a prediction of the apple. We now do have a situation where we want to penalize our model for predicting some cherry as an apple, when in actuality it's not. How do we take this into account in our formula now? We go here, all right? Now, what happens? The denominator changes. The numerator, everything stays the same. It's the denominator that's changing. What's happening is, in our right node, for every cherry we have, we're going to make it hurt. We're going to multiply it by 5. We have 3 cherries. Therefore, each cherry will be multiplied by 5. So 3 times 5 is 15. All right? We don't do that for apple. We don't do that for orange because there's no penalizations there. All right? So now it's going to be 4 plus 15 plus that 1, which is 16. So this is going to come out to 1 divided by 16. All right? Again, 4 apples, 3 cherries. Oh, no, I'm sorry. Did I do that right? No, it's actually bigger than that. Let's do that again. So 3 cherries, 3 times 15. 15 plus 4, 19. 19 plus 1 is 20. The denominator has become 20. Why? Because we have 4 apples, 3 cherries. 3 times 5 is 15. So basically the value becomes 15 for cherries and 1 orange. So that becomes 4 plus 15 plus 1, which is 20. So the first one becomes 1 divided by 20. Oh, I'm sorry. The first one is for apples, 4 divided by 20. Then we have our 3 cherries, and that is going to be 3 divided by 20. And then finally, it's the orange, which is 1 divided by 20. Now, why do we do this? We do this because what happens is these fractions become smaller. Because these fractions become smaller, 1 minus whatever these smaller fractions are is going to be a higher number. And as you can see, that Gini score just got blown up, right? And so what happens here is any situation where we have a rule that's going to misclassify cherry is going to get an extremely high Gini score, which is going to give the other Gini scores a better shot. That's how the loss matrix penalizes the Gini score. All right, so we go here, and now I do my average. And the average is straightforward again. So the average still will be 3 divided by 11. And 8 divided by 11. And that's our Gini score. It got wrecked. That's the idea behind this, guys. Let's do 1.8 now. 1.8, less than 1.8. Where are we adding? Cherry, orange, apple. All right, so we just added an additional cherry. It looks like that. Right? Because now I have cherry, orange, apple. So now we have 2 cherries. Oops. We have 2 cherries, and here we lost the cherry. And this becomes 2 cherries, all right? All right. Again, this side finally is predicting cherry. Excellent. So I come here, I do prediction cherry. There's no penalizations. This is straightforward. This is going to be 1 divided by 4 minus 2 divided by 4 for the cherries. And 1 divided by 4 for the orange. All right. Come here now. What's the prediction here? It's apple. Oh, I chose a good one. It's apple. All right. Or should I say I switched it to a good one. So now I have 4 apples here, right, guys? The prediction is apple. I come here, got to penalize the cherries. we got 2 cherries in there. So what does this become? 4. First, let's do the cherries. Cherries is 2. 2 times 5 is 10. 10 plus 4 is 14. 14 plus 1 is 15. So now the denominator becomes 15. All right, 4 divided by 15. 2 divided by 15. And 1 divided by 15. Come here. Now it's going to be 4 divided by 11. Seven divided by 11. And the Gini score, it's got slightly better. Got slightly better. Come to 1.9. What is less than 1.9, guys? All right. Apple. Cherry, cherry, orange. That's it. Less than 1.9. This apple. Less than 1.9. Did I do that right? So this apple, this cherry, that orange, and that apple. Okay, yeah, I did this right. All right, we just added an additional apple. That's what's happening here now. So I have 2 apples, 2 cherries, and an orange. And unfortunately, again, we have that situation where we don't have a clear winner. That's right, I'm going to cheat, make it a cherry again. So this becomes 3 apples, 5 plus 6, perfect. Ladies and gentlemen, I'm cheating again. I'm just going to say, okay, cherry was the largest one here. Now, cherry was a prediction, so it's going to be straightforward again. Two divided by 5. 2 divided by 5. 1 divided by 5. All right, now here we have 3 apples, 2 cherries, 1 orange. We still have 2 cherries. So this becomes 3 plus 2 times 5 is 10. 10 plus 3 is 13. 13 plus 1 is 14. Denominator is now 14. All right. So now it's going to be 3 divided by 14. 2 divided by 14. 1 divided by 14. All right. It's going to be painful. 5 divided by 11. 6 divided by 11. All right, it's a better number. Better number. All right, finally our last one, 2. So less than 2 is going to give me, actually, where's the 1.9s? Less than 2, we got a 1.9 here, so an apple. So we have an additional apple goes there. All right, so less than 2, I mean, it's probably easier to do greater than equal to 2. So what's greater than equal to 2? Let's do the other side. Greater than equal to 2 is cherry, apple, cherry, orange, and apple. Two apples. I'll flip it. I'll just do the other one. Cherry, apple, cherry, 2 cherries, apple. Oh, an orange. Okay. Cherry, apple, cherry, 2 cherries, 1 apple, 1 orange, and 2 apples. So 2 apples, 2 cherries, 1 orange. So on this side, what happens is pretty much lose one of the apples. Makes sense. Now on this side, we gain an apple. All right. Let's do the math here. Finally, we're predicting this to be apple. The left side is now predicted to be apple. And we come here, it's the penalty. It's the penalty. All right. And so we have 2 cherries, which is 2 times 5 is 10. 10 plus 3 is 13. 3 plus 1 is 14. All right, so I'm going to take this one because that's the 14 denominator one. Bring it here. And so it's 3 divided by 14, 2 divided by 14, 1 by 14 is basically the same one. I come here, 2 apples, 2 cherry, 1 orange. That was basically this guy. Move that over here. 2 apples, 2 cherry, 1 orange, right? And so now, this is probably going to be the same one again. Oh, please don't do this to me. It's going to do this to me. 6 divided by 11. And 7. 5 divided by 11. And it's going to be the same value. Oh, God, it's going to be the same value. All right, so in this situation, what has the bigger distribution, guys? There's 1.9. And there's 2 2s. Oh, I'm sorry, 3 2s. Oh, wow, okay, 1, 2, there's 3 2s. All right. Okay. All right. All right. All right. So 2 has a bigger distribution. I'm sorry. This one has a bigger distribution. So, I mean, this one has the most values. So we'll just stick with this one. I mean, usually you don't have a situation like this. We have same score like this. We have very little values. So we'll just take this one because it has more values. So we'll take this one, all right? So less than 2 in this case is, this, whatever. 2 is our splitting value. This is our Gini score, right? I think the original question was, oh, it's splitting value for the first. Okay. So in this case, we calculated for sugar.level. We now have to go through peel.width. So now we have to go through peel.width. So I'm going to go here, copy this again. So for sugar.level, we got our answer. We now just have to compare it against peel.width. God, I hope peel.width does better. All right, so peel.width. Let's look at the values. All right, I got 0.2. I got 0.4. 0.5. 0.5, 0.6, there's no 0.6, 0.7, 0.5, there's no 0.6, 0.7, 0.8, 0.9, and a 1. All right, and a 1. All right, so let's see which makes the cut. 0.2 is not going to make the cut. 0.4, all right. We got 1, 2, and that's it. 0.4 doesn't make the cut. 0.5, 1, 2, 3. 0.5 makes the cut. All right, up here, let's see what makes the cut. 1's not going to make the cut. 0.9. There's only 1. 0.8. Okay, so 0.8 is going to give me 1, 0.9, and 0.9, so 0.8 makes the cut. Excellent. So I only have 3 values to check, which is going to be fantastic. All right, so let's go ahead and go through the same razzmatazz. All right, less than 0.5. Boom. Let's look at what's less than 0.5. It's It's going to be 0.2, 0.4, and 0.2. These guys right here, the first three rows, fantastic. Oh, no, we got this guy, this guy, this guy, and this guy. Look at that. 4. So it's going to be 1, 2, 2 apples, and 2 oranges. Great. Have to do this to me. 2 apples, 2 oranges. All right, I'm going to cheat here again and say apples is the majority one. All right, so apples will be majority in this case. Cheating again. And everything else goes on the other side. So that would be, what? That would be 1, 2, 3, 4, 5, 3 apples. Oh, this might not be a good idea, but 3 apples. How many orange? How many cherries? 1, 2, 3, 4 cherries. And oranges. No oranges. All the oranges are on the left side. You know what? In that case, fine. Oh no, cool. It works out perfectly. All right, excellent. 4 plus 7 is 11. Excellent. All right. So if it's less than 0.5 and the peel width, it's an apple. If it's greater than or equal to 0.5, it's a cherry. Sweet. Let's do the math. All right. Come to my loss matrix. Here, if there's a penalty, I gotta penalize cherry. I gotta penalize the model for incorrectly predicting a cherry as an apple. We don't have that situation here. There's no cherries here. It's straightforward. All right. In fact, I know what the answer is. 2 over 4 divided by 2 over 4. It's gonna be 0.5. All right. Now we do the greater than or equal to. This is predicting cherry. Again, I come to cherry here. Cherry has no penalties. This is straightforward too. All right, there's only 2 of them, so let me delete this. So this is going to be 3 divided by 7. And 4 divided by 7. No, that's not right. Yeah, that's right. Okay, there's 7 values. 3 divided by 7, 4 divided by 7. All right, sweet, excellent. I go ahead, I do the math. Oh, come on, let's copy that. Four divided by 11. 7 divided by 11. Boom. Small Gini score. Huh? Very nice. Very nice. All right. 0.7. See what we have here. 0.7. Less than 0.7 is going to be this guy again. That guy. That guy. That guy. That guy. All right. So 1, 2, 3. 4. 5. Okay, we got a 0.5 up here. All right, so we picked up 1, and that's an apple. We picked up an apple. Perfect. And so that's 3 apples. Excellent. All right, so this is now more cleaner. And again, I come here, apples, incorrect, predict cherries incorrectly. There ain't no cherries, so I'm good. All right, and over here, we lost an apple. This becomes 2 apples and 4 cherries. And again, cherries has no penalty. I'll come over here. Let's rework the math. This is going to be 3 divided by 5. 2 divided by 5. Bam. Come here. 2 divided by 6. 4 divided by 6. All right. It's an even better score, I think. 5 divided by 11. And this side will be 6 divided by 11. Yep, I was right. A better Gini score. All right. We're getting there. Finding the last one. All right, guys, the last one will be 0.8. And so let's see. How many 0.7s were there? 1.7 here. And looks like that's about it. And that is a cherry. All right, it's our first situation with the cherry. And there's 1.7. All right, so the left side now picks up finally a cherry, which is going to cause all kinds of havoc. Because the left side is predicting apple. And as you know, predicting an apple, when there's an actual cherry in the place, is going to cause massive errors. Over here, this becomes 2 apples and 3 cherries. So right side is still predicting a cherry. All right. We got the penalty. All right. 1 cherry. That's 1 times 5. 5 plus 2 is 7. 7 plus 3 is 10. The denominator on the left side is now 10. All right. So that's 3 now divided by, hold on. We got 5, 7, 10. 3 divided by 10. 2 divided by 10. And I have to add another one for the cherry. 1 divided by 10. One divided by 10, yes. Bam. The right side is a little cleaner. Oh, because the right side now we're predicting cherry. No penalizations there. So that's still good. So now it's 2 divided by 5. And 3 divided by 5. All right. The math. The left side is 6 divided by 11. The right side is 5 divided by 11. All right, and we got a higher Gini score. Now, we come here. What's our best Gini score out of all these guys? Thank God we have a tiebreaker, and that's this one right here, guys. Right, that's this one. It would be 0.7. 0.7 from peeled out width. So, we calculated now what our Gini score, impurity score for everything is, and our splitting value for the first split is going to be peel width less than 0.7, greater than equal to 0.7. This is with the loss matrix. All right? That is how the loss matrix changes everything up. We are now finally done with our practice set, and hopefully you guys are now ready to go for the next class. All right, guys, have a great day. I'll see you guys at the next session or in the next module. All right, bye-bye.